most of you joined. Let me see. 16. Okay. So we are going to start this course, Embedded Communication Networks. So here, Professor Sharkar, Professor Anup Sharkar and me, we both will be teaching this course. Half part, the initial few parts, few protocol level details I will be talking about. And after that, distributed dependability of embedded networking, and those parts will be taught by Professor Sharkar. So this is your class timing. Hope it is okay for everybody. This is a link. I will share this presentation with this Teams link, and this link, this is a shared drive link. Here I will upload all the course materials, study materials. You can refer to, and in that shared drive, I have already uploaded your syllabus. I don't know how many of you seen. Maybe it is shared in ERP also. So this is the overall course syllabus, where we will be talking about the challenges of real-time protocol, then a few communication protocols related to embedded systems. Then we will move to some advanced topics like some problem is there. Okay, maybe I can show it from here. So this is the course outline. So in the first week, we will be talking about initial networking concepts and why this traditional networking concept, traditional communication concepts are not suitable, and what more changes need to be done when we are talking about real-time scenario. Second week, next we will be talking about some detailed communication protocols related to embedded systems, UART, USRT, I2C, and then we will move to, because nowadays embedded system is a pillar, or we can say extended embedded system is IoT. So we will talk about some protocols, at least not exact protocols, but at least what types of protocols, what type of frameworks we can think of when we are moving IoT with embedded systems. Then it's related error detection and correction. And after that, we will talk about some typical communication protocols to specific domain, like initial vehicular communication. For the in that communication, we will talk about CAN. That some discussion of CAN we have talked in our fundamental course. I don't know, a few of you must have attended that course also. And then FlexWay, MOS, LAN, time triggered Ethernet. These types of communications required vehicular communication, which is one of the most prominent application of embedded system. Next, we will move to communication requirement and what type of protocols used in smart grid and industrial communication. Sorry, this is wrong. Okay. So there we will talk to typical protocols. One is general smart grid requirements in terms of communication, that is much different. There is some typical requirement is there in smart grid scenario. We will talk about that, and then Modbus, that is required for industrial communication, and JTAG also. Now, where we will be talking about these type of tools, these type of communication protocols related to embedded system, we will also be talking about few tools. But one of the tools, we will try to develop some small demo, small projects on this Canoe tool, where we will try to simulate a small CAN network, and maybe we will, this time we will be working with some demo version. There we will try to do some CAN framework and also try to simulate some FlexWay and LAN framework. Okay, so this is the tentative course plan for initial few 6 weeks. In the next few weeks, Professor Sharkar will be talking about the distributed dependability and those parts. So this is the course tentative course outline. Detailed course outline, you can see in the shared drive. I have already uploaded the syllabus. There you can get everything. Okay. Now with this, I want to ask you, since most of you from different backgrounds, I want to ask how many of you I know about few students were from the fundamental course of FECS, and some are from our ATDC MTech. Other than that, few students are there. They're from different departments. So I want to know how many of you actually have some idea about networking or communication concept, or you have done any course on this communication or networking. Is there anyone who doesn't have any concept about networking or communication?
Yes, ma'am. It's me, Shreyam.
So you're from which background? Can you please?
Metallurgy and Materials Engineering.
Okay. Anyone else? So other than that, everybody has done some course on embedded system, right?
No, this semester we are having embedded system.
You are having embedded system. No, I'm not talking about, sorry, not embedded, not talking about embedded system. I'm talking about communication. Have you done any course on communication?
Analog communication?
No, I'm talking about digital communication or general communication networks concept.
No.
Okay. No, right? Okay. Then today I'm not starting anything. I will just discuss about few basics. Mostly those who are who have done some courses on communication. Maybe this is a repetition for them, but just to give you an idea what we understand by, I mean, what we expect from communication courses, and how this embedded communication requirement is different from that. Okay. So let's start with these. So when we are talking about in general communication, wait. Wait. Is it visible? Is the slide visible?
Yes, ma'am.
Okay.
Yes.
So when we are talking about network, because this course is embedded communication network, for that for this we have to deal with first we have to understand what are the challenges in embedded domain, for which we are again talking about a separate course or talking or doing a few separate discussion considering the facts of embedded scenario. But before that, what is there in general communication or general networking? Now, when we think about networking or network, it is some group of computers or say some devices connected. Now, when this device is connected, first thing you need to have that. First thing you need to understand that when few components, maybe these are computers, devices, I'm talking about the general network. Later on, we will come to embedded network and we will see how these components are entirely different other than compared to the general form of network. Anyway, in general network, some computers or devices, they are connected in some way to exchange data. Okay. So when I'm connecting some component to some network, that means there should be some identity of that component by which other components present in the network can identify that particular component. And for that, the requirement is some unique address. So when some component is connected to your network, it should have some unique address. Now, in general communication, we see our network, our computer systems are connected with some maybe network interface card, and they assign some particular numeric addresses. Let's say this one, this type of numeric addresses to that computer. Okay. So the idea is for that there should be some protocol how I am assigning some address to my component present in my network. And from there, the concept comes of internet address. There are some protocols how we are forming that internet address. These are, in general, these are 4 bytes, and the initial few bytes are related to some networks. And when you are entering in a particular network, it may happen that network is consists of multiple hosts, multiple computers, or multiple computers or other devices. And so some net ID and some host ID should be there, where the initial part of your address represents some network ID, and the latter part of your address may actually indicate the particular host present in that network. So that is the concept of addressing. That means this addressing is important to identify any component in your network. Okay. Then the domain name system, that is a general requirement of internet system. We are not going into that because DNS requirement is not there. You can actually read this as a basic of your understanding of networking. But in general, when we are talking about embedded networking, there also in embedded protocols, you will see some address is present to identify your embedded components in your embedded network. Next, you have attached your component to your network. You have assigned some name, and here the particular name is the address assigned to that component. Next, your next requirement when you are forming any network or starting any communication or understanding in this communication is that through your computer or through your device, what type of data exchange is taking place. In general communication, you can see these data, this type of data exchange can be anything. It can be file transfer, it can be email transfer, it can be general HTTP type of transfer. So based on the type and based on specific application running, the next requirement is port, right? That means first is requirement whenever you are talking about any networking discussion, first thing is what are the components, how you are identifying the components, that is address. The next requirement, what your components are doing, that is what type of communication is taking place, and particular communication in general networking I'm telling, maybe that we will see how it is different in some cases, because maybe all these requirements may not be present there when we are moving to embedded domain, but I'm just giving one basic idea about general networking, where port is a type of port is a requirement. Maybe you have also already seen that HTTP port, FTP port, when you are setting the proxy, you have to give enter some values. Those things maybe you have seen, and the requirement is that based on type of your data, type of your communication, these ports are used. Okay, next comes the data transmission. Now you have everything, you have your components, you have some addresses, you have some name, that is the address based name of your components, and then few of those components, network components, they want to transmit data to each other. So in that case, how your data should get transmitted through the network bus, or how this transmission will take place. Based on that, there will be some discussion on how you are actually modifying or representing your data, better to say. So for that, you are basically dividing your data into some smaller data set, smaller packets, and that packet should also hold some information, header information. Now, why does header information is important? When you are talking about a communication scenario, a network scenario, there may be multiple senders and multiple possible receivers. it is important, and it will also differ protocol by protocol. We will see that how any protocol is actually identifying its possible receiver, how it is indicating in its packet, how it is indicating its possible receiver. So this type of source address information, destination address information, and we will just talk about a few other things like CSC, some other possible bits that is incorporated in this header part. And those are important. This structure is important for the data transmission. Also, another important thing, when we are choosing multiple protocols, we will see what is the size of actual data we can transmit in this data transmission process or the data transmission protocol is we are choosing. Now, when we will move on discussion, maybe next day we will start with that. In embedded scenario, we will see in embedded scenario, one typical challenge is that you have to complete your transmission within a specific time. You have some requirement of deadline. We talk them. Sometimes it is hard deadline, sometimes it is soft deadline. But embedded system communication or anything related to embedded system, anything related to cyber physical system, when we talk about, we consider that it is related to real time. That is, your communication need to be completed within a particular time frame. Otherwise, if your communication or your framework is missing that deadline, sometimes that is catastrophic, sometimes that is losing its importance. Based on that, we classify. We will talk about in detail in next day about embedded basics, but sometimes we talk about that if it is catastrophic, it is hard deadline. If it is losing its importance, it is soft deadline. So anyway, how we are choosing the protocol and how we are packetizing this data and total header and data, what is the ratio? Those are very important factors when we are choosing our embedded protocol. But in general communication, this is the concept that when we are interested to do any data communication, basically we are dividing the whole data in smaller packets. Then comes the types of networks. Types of networks means, of course, you know that there are, if some closely related networks, then we can call them LAN. And if the communication is in wider range, covering cities, countries, etc., we talk about WANs, wide area networks. So these are the basic concepts of types of networks, maybe. But the important thing is that when we are talking about communication, maybe look LAN, how we are arranging our components. And based on that, what are the different types of arrangements possible and how they are actually affecting our communication. Now you can see here, this is a shared bus communication. Maybe those who have done their fundamental course, they know that this shared bus communication we will again see in CAN. And there are some advantages and disadvantages of these type of ways how we are arranging our communication components. And in case of fault tolerance, error handling, how they are actually acting differently. For example, if we think about this shared bus, if some fault occurs to one system, we may directly remove this component and they may not affect to this to the components present in other framework. Other parts of the framework. But when we are coming to this ring part, what happens if there is one fault? Maybe this component, network components is faulty. It may affect the communication between these parts also. So this way, there are different types of arrangements possible, and we will see which type of arrangement is more suitable in case of embedded scenario. Okay, and this FDDI LAN, I'm not talking as of now, because this so based on that, maybe you can see when we are talking about general communication, now what is my idea about a communication network? There may be different network possible. See, this is one network, this is second network, this is a third network. Now these networks, if you can see, these networks in between their components are arranged in a typical separate way. Okay, here you can see the components, the computers, they are connected in a shared bus. You can see here in this is a token ring structure where the components are connected in a ring fashion. This is connected by a bridge. Okay, we will talk about this, how this bridge and all these are different. This is a separate connecting mechanism. And here these two, this Ethernet base and token ring base, they are again connected by a separate router. Right, router means, let's say any communication is taking place from one source of this network to another destination to this network. So in that case, what will happen? These communication requests will come to maybe this bridge, this connecting point. From this connecting point, it will go to this router. Now this router may have some mapping, which will see these destined requests where it is interested to go. Whether it is interested to go to some component to this network, or to this network. Based on that, the mapping of destination path will be done and the request will be sent to this particular network in this token ring based LAN. And this way, the whole communication will take place. That means the idea is when we are talking about general communication, all the networks are smaller networks connected maybe in similar or maybe in a different way. Different protocols are working on them. We will come to what we understand by protocols later on. But at least as of now, I think you can understand that maybe different numbers of components, different types of components, and they are connected in a different way. And together, when we are successfully designing a framework so that any node can communicate to any other node through this different types of communicating medium, maintaining different types of protocols, then we can call them it as a successful communication framework. Okay. Now we will start about what we understand by protocol. Is there any question up to this? Wait. Let me go there because. Is there any question up to this? This is whatever I'm talking, a very basic concept of networking. What we are interested to do in networking and how things run in general communication. Okay.
Hello, ma'am.
Yes.
In the diagram, what is frame relay, frame and ATM are doing?
Pardon?
In that main diagram, what is frame relay and ATM? What are they doing?
As ATM, right? Asynchronous transfer mode. Okay. Now this frame relay, this is also a connector, but these are some typical, communication requirement or protocol requirement, because frame relay or this type of communication mainly works in one type of scenario or bigger LAN type of scenario. So this is also, you can think about a connector, how it is connecting these separate LANs. Okay.
Okay.
Okay. So far, maybe it is clear that when we are talking about general communication, our basic idea is we have some components, they have some addresses, and they have some ports assigned for different types of communications possible, and they are getting interconnected through different type of interconnection, like you have seen here: bridge, router, this frame relay, everything. Then comes the protocol. Okay, now so far we have talked about how they are connected, but protocol actually defines how this communication is taking place between two computers or between two devices connected in a basic network. Okay, so basically protocols mean defining the rules. Okay, so HTTP, this is an example of a protocol. Actually, we will take in detail, but when we will talk about the IoT scenario, how the versions of HTTP is important. But as of now, this is just a name of a protocol. Okay. So protocols, when we are talking in a network scenario, now you can see that there may be different layers of communication. Like when when multiple LANs are connected together, that means when one host from any LAN is trying to communicate to another host of any other LAN, first it has to come out from that particular network. Then it should follow some routing protocol or go through some router to enter to a different LAN, and in that LAN there should be some identification process of a particular node. So all this, some communication should be there inside that LAN, some communication should be there in the router level, where router means that is a bridge, maybe that is a connector between two LAN networks. And these two networks, when from this of source and the receiver, they may not be following same types of protocols. Maybe one protocol, we can go back here, maybe some protocol is governing the data communication within this LAN, and some other protocol is governing the communication between these LANs. So they are maybe entirely different, but this translation is required, proper translation is required. That's why there's some gateways, we also say these are just terms so for proper translation from one protocol to another protocol. But as of now, we understand that protocol means some rules that is governing the communication between two nodes of a particular network. Now, when we are talking about communication, talking about protocols, in general communication, these protocols are divided into different layers. Okay. And this is OSI model is a typical general data model that is supporting the layers of communication. Now, what does it mean by this 7 layers? Maybe any way is possible. You can come from application layer. It is easy to understand. Let's say any host is starting any application, and for that application, it is requesting for some data exchange. So from that application layer, some message is getting generated that should be transferred from one host of a particular LAN to another host to another LAN. Okay. So what will happen, as if you think about what are the few terms we have discussed so far. First one is that there should be some particular address related to that host in that network. So that particular addressing part is handled by this network layer. Okay. Next, we talked about different types of applications, and for that applications, we map them to different ports. So this port-to-port communication, along with some confirmation of error detection, correction, confirmation of end-to-end communication, etc. All these things are promised by this transport layer. Next comes the data link layer. Data link layer, here we will see basically from tomorrow onwards, we will go more detail of this data link layer and see what are the requirements we have to incorporate when we are talking about embedded communication. But as of now, you can understand, like if you go back to this example of shared bus, maybe come back to this example of shared bus. Okay. In this shared bus, multiple computers are connected in general scenario, and it may happen that when this computer is starting its communication, it is also starting its communication, and there may be a possibility of collision. So this collision handling and proper communication, maintenance of proper communication in shared medium, all this is guaranteed by this data link layer. Okay. So this is basically for safe communication. That's why it is written. This is the safe communication for data over physical network. Now, physical network means this. Next, it comes the physical layer. Now, physical layer means what does it? When we actually sending some message, it may be in any form. Maybe it is hypertext transmission. Maybe it is file transfer. It may be in any form. But at the end, if we actually go to the underlying basic switches, underlying basic communication, it should get mapped to some 10 format, 1010 bitwise communication. Now, what will be your bit level communication format, and how this bit level representations will be understood by different, maybe change of voltage levels, how it will be physically realizable. Those things are taken care by physical layer. Okay. So now we have we can map whatever terms we have discussed to each and every layer. For physical layer, we are representing our data to our basic bitwise level, bit level synchronization, how your bits will get mapped to some voltage level. All these things are taken care by physical layer. Once that is done, then your data is actually in some medium. Now, how your medium will resolve the communication issues, how your medium will resolve any kind of collision issues, everything is handled by this data link layer. Okay. Then it comes about the network layer. In network layer, what happens? You are actually packetizing the data. You are actually dividing the data, making it a packet. You are giving source address, destination address. You are adding everything, so that now based on these data format, you can understand from where it is coming or from where it is going. And then it comes the transport layer. In the transport layer, we are confirming the port-to-port communication. Initially, basically you can think like this, that in network layer, you can think about one node-to-node communication, and in transport layer, final port-to-port communication with this error correction, detection, all this part is confirmed. Okay. Next comes these two that we have not mentioned. These are session and presentation layer. Now in session layer, what happens? When any host and any destination, there is a communication. It may happen that it is not always necessary. We will see some other types of layer models where these parts will be clubbed together. But idea is that how some sessions are established for safe communication of your data packets. So that is the session layer. So we'll talk more with some examples with for this. And then the presentation layer, that how your standard data representations is possible, and how you're adding some added features to your data. So I'm just skipping as of now. We will actually discuss this when we come to some particular protocol. We will talk about these 2 layers, whether it is important or not, or what we understand this in embedded scenario. We will talk about this. And application layer, as we started from there. From applications, we are getting the data, and it is in this way, it is traversing through this network. So basically, OSI layer model, this is a particular layer-wise view of whatever operations you have to confirm in your overall communication framework. So this is just a OS. It is giving you the concept of the overall functionality in different layers. Now, actually, if we now club together a few layers of OSI model, then this is another model that is called TCP/IP model. Okay. Frankly speaking, TCP/IP was proposed prior to OSI, and after that, more granularity was added, and then comes the OSI model. But if we think about this TCP/IP model, here based on these 4 layers, some functionalities of OSI layers are actually clubbed. Actually, this network layer, if you remember what we talked about, this physical and data link layer, these together form this network layer. Okay. So this network layer, what it confirms? It confirms how your data can be realized bitwise or some form of smaller fragments. And then with that fragment, how this communication is confirmed, also in case of shared media. Next comes this internet layer that you can map actually to the networking layer of your previous OSI layer. Okay. So in this internet layer, they make the datagrams. I will come to how it looks like and everything. And it handles routing, like the addressing. Like if you remember, if I go back here to this diagram, when any data is coming to this bridge or this router should take the decision based on some inputs from this data packet which is coming to this router, that in which direction that packet should go. So that mapping and that decision making protocols are designed in this internet layer. Again, the transport layer, it is almost same, that is end-to-end data delivery. And this application layer, basically this application layer is the merging of these 3: session, presentation, and application, where we talk about that session establishment and presentation and also application handling. So TCP/IP layer was initially proposed with this concept, and this more granularity was added to modify it to the OSI layer. So whenever we are talking about communication, this layer concept should be clear in your mind, like these operations my protocol should confirm, or rather on the opposite way, I should know whenever I'm talking about any protocol, exactly which layer it is serving. It is not necessary that a protocol will serve the requirement of every layer. Specifically, we will see most of the protocols when we will discuss, we will see it is basically catering the need of a particular layer. That means it is basically defining the rules for a particular layer. And then it is sending the data to the next layer to be processed. So that way, but whatever operations we require in an overall communication from framework step by step, those are basically layered in this format. Layered in this format, and they're basically, when said, these are divided in smaller chunks, smaller blocks, and those rules are defined for those blocks. So that is the concept of TCP/IP model, and the whole communication concept is divided in these layers. So that's why whenever we will be telling any protocol, we will be discussing any protocol, we will say this way, okay, this protocol is for this layer. Then you automatically understand what to expect from that protocol. For example, if I am telling that I am talking about maybe I can, if I go back to OSI layer, if it is a more detailed observation is given. If I'm telling you that, okay, I'm telling a protocol, today I'm going to discuss a protocol related to data link layer, you will automatically understand that this protocol should tell us about something, that how I will manage the communication in a shared medium. It will not going to tell me that how my data will be segregated or segmented based on some application. That is the functionality of some other layer. But when I'm specifying some particular protocol, particular algorithm for a particular layer, so that is basically deliver the main objective of a particular layer. Okay, so that's why whenever we are talking about communication in general, this OSI or the concept of TCP/IP and this concept of at least OSI layer, that should be clear in your mind. And then from next year onwards, when I will actually start discussing about our embedded communication network, you will see each time we will go in detail. Maybe next year we will go in detail of some data link layer protocol in traditional domain, and we will evaluate it whether that is suitable, that is proper for our embedded communication need or not. Then, or what modifications we should impose on that algorithm so that we can accept that for our embedded communication scenario. But for that, of course, first we will discuss what are our embedded communication domain requirement. First we will do that, then we will start doing. So we will from next maybe 1 week we will discuss about this data link layer protocol that is most, and physical layer protocol that is most required in our embedded domain. Then when we move to the IoT discussion, IoT communication discussion, there we will see some what to expect from this application or presentation layer protocols. So that's why we have kept the back-to-back discussions of embedded communication protocols and IT communication protocols, and then we will move to some application specific protocols. Okay. So any question up to this? Any question? Any part you want me to repeat? Okay, for those who are not having any background of communication, what I will suggest, actually in the shared drive you will go, and I have already kept a book on embedded, basic book of embedded communication. See, from data link layer we will discuss in detail in the class, because we have to check whether those algorithms are suitable for embedded domain or not. But at least for the first part, first first physical layer and the introduction to this OSI model, this first chapter you go through it, I will suggest, then you will get some idea what to expect from any communication layer, what are the main fundamental operations decided for any particular layer. Okay. Is it okay?
Yes,
Are
ma'am.
you there?
Yes, ma'am.
Ma'am,
Okay.
where have you put that shared drive link?
Okay, this is in this presentation I've shown, right? I will share this presentation with you. Maybe I can wait. This is the link.
And these PPTs will also be shared or not?
Yes, everything will be there, and also you will get a basic book. So maybe the first chapter you go. Whoever not having that background, the first chapter at least you can go from that.
Okay.
So this is the shared drive folder. This is the syllabus, detailed syllabus you can get from here. This part I will start next day. This is a real-time communication requirement. And in this folder, there is a book. You can actually go through the first chapter from this book. You get the idea. Okay. Okay. So next. Okay. So I think so far you have some idea about what are the layer concept in communication and why these layers are important and what are the typical tasks they are assigned to. Next, we will just take an example and we will see that what are the typical protocols assigned to those particular layers and what are the challenges we may face when we are directly choosing them in embedded scenario. Now, when we are talking about TCP/IP model, the main you can understand that the main basic building block, protocol here is the IP protocol, and another one is the TCP protocol, where this TCP protocol is basically for port-to-port connection, port-to-port delivery confirmation. And IP is for data fragmentation. Like you have some data and how you are fragmenting that to packets. What are the typical features you are adding to them? All these things. Okay. Now, on top of these, you can see these IFTP, Telnet, SMTP. These are application layer protocols. This is something for file transfer, something related to mail transfer protocol. So whenever based on your application, these application layer protocols are there. This is for your delivery confirmation. This is for your how you are managing your data. And this one is for your physical and data link layer protocol that is merged in TCP and named as network layer. Token wing. Token wing means those are confirming how you are actually arranging your components. Like the Ethernet protocol, they are confirming how you are actually handling your shared media. So all this network layer or in this TCP/IP network layer, but if you name in terms of OSI layer, and I think when I said it, that is clear for me, because in OSI I can clearly understand that data link is for shared medium handling, physical layer is for bitwise handling, those way. So anyway, in TCP/IP, these are for network layer. This is for internet layer. TCP/UDP, this is for transport layer, and the final layer, this is for application layer. So now if we've taken one general example of a general network, what you can understand that when these type of different networks are present, when they are separately communicating to each other, then shared medium handling is only sufficient. That means at that time, only if you have proper this Ethernet protocol or token ring handling and these type of protocols, they are sufficient to communicate between this shared medium and from one node to another node within this shared medium. But when you are actually trying to communicate from this node here to maybe this node there, then what you have to understand, how your communication is taking place within P4. Then when you are coming out of P4, your protocol is internet protocol. That means you are actually fragmenting your data in some way, and you are sending, let's say, packet by packet. As of now, just you can name them. We will see how we are actually forming those packets. And then this IP we are sending through this after this IP packetization, we are sending to this another LAN, where inside that LAN, again the communication is actually taking place either by this Ethernet or by token ring or anything. We don't know. Based on the requirement of this LAN, maybe some other protocol is governing the rule. So IP, then Ethernet. Now when we have reached to some host in this P2 from any node from P4, then the exact port-to-port communication is actually confirmed by TCP. We will see how this TCP and IP functionalities are different and how we are generating in which form this data or from which applications. That is governed by this either FTP, Telnet, SMTP, all this application level protocol. Now you see, we can go here that when we are talking about packetizing my data, when we are actually, I have a huge data stream, or I have some FTP level inputs, I have some HTTP port level inputs. But when in IP, by IP protocol, we are packetizing them, what does it mean? Basically, we are fragmenting my whole data into smaller packets and we are adding some features with that. Now that's feature, as from my our first slide we talked about that feature maybe a header that is basically giving the idea, that is basically incorporating the value of destination address. In some cases, source address is also required. We will see protocol that will vary. That in some cases, source address is given. In some cases, to receive back some acknowledgement. In some cases, that is avoided. Now, we can argue that when I'm giving the source address and I can get the acknowledgement back, so that I have the confirmation, okay, my packet is delivered successfully, properly. But what is the purpose of not giving that source address? The purpose is that when I am avoiding to add that source address to my packet, sometimes it happens, it is saving that much of bit to add some added data bits. That means my data bit actual data size is actually getting increased per packet. And that is important to determine what is the data speed I am allowing. And that is also based on what is the requirement, especially when we will be moving to our embedded scenario. That is important to choose because their deadline is very hard or fast. And so if you have to complete your transmission of a particular stream size of data, then and within a particular time, then it may happen you do not have the luxury to allow some of the bits just for acknowledgement. So based on your requirement, based on your constraints, your protocol need to be chosen wisely. That's why different protocols are there. Different protocols are there to use them in different purposes and getting to be used based on different constraints. So we will see those in the coming protocols. This is one is header. Next one is the checksum. Checksum is mainly for error detection, correction, those things. We will talk this, maybe some of you already know, so we will quickly talk about that later on when we talk about error detection, correction. Next is source address, destination and separately is there. Then this header field also sometimes keeps some count and all these things. Some options based on the protocol. So together, actually, though this part only here given as header, but these together is actually you are using, maybe you can say extended header part that is not actually transmitting your actual data. Maybe each of these fields, they have some typical importance in terms of error detection, correction, sometimes acknowledgement receiving, sometimes fault tolerance, sometimes security, everything is there. But sometimes different protocols need to be chosen to save data bits for your actual data communication or to improve the performance of your communication. So that way, this is just the example of your IP protocol, but you will see, we will discuss different types of protocols and you will see these structure, these data fragmentation concept is same, but the structure is getting varied. Next comes the concept of transmission control protocol, TCP. What happens there? TCP is important when IP fragmented packets, they need some guarantee of safe data transmission. That means from client to server, it may happen you can send the data directly and you are not concerned about whether the data is actually transmitted or not. You are confident that that is also based on your type of communication. In some case it happens, we will see that you are sending similar data packets repetitively. So in those cases, it is okay if 1 or 2 packets are lost and your receiver still can continue with the rest of the packets and build up the overall data stream. But in some cases, it is absolutely mandatory to delivery of each and every packet. Otherwise, your final data stream in the receiver side cannot be formed. So in those cases, case to case specific, either this acknowledgement is required or this acknowledgement is, you can actually leave it. You can actually tell it, okay, I will not follow that. I'm not going in this TCP direction because it is having some extra overhead. Whenever you are sending some waiting for some acknowledgement, that means you have to create some dedicated transmission session between your client and server. So how can you do that? You have to send some signal to receivers from, the client should send some signal to the server that, okay, come in sync, we are not now going to start the data transmission. Once server is receiving that synchronization request, it can send some synchronization acknowledgement. Okay, I am in sync. Now send the data. Receiving that, client may send some acknowledgement. Okay, I have already received your sync acknowledgement. Now I'm going to start the data transmission. Then again, data transmission is taking place. Then the data transmission should start. Maybe it is from one direction, from client to server end, or from both directions, from client side as well as server side. So based on that, there must be some dedicated synchronization signal communication first to establish the connection, and then the data transmission will start. So you can understand for this, there is some extra overhead, in terms of signal maintenance, in terms of timing requirement. And sometimes in real-time scenario, some critical time critical scenario, you may not have this luxury to allow first allow separate synchronous signal to send and receive by client and server, and then to start your communication. For this, you have other options like UDP, that is totally a connectionless protocol that just sends data from client to server side, but this typical connection establishment is not there. That's why TCP, we call it a connection oriented protocol. So these are the few typical concepts in overall communication protocol, which are very important, and why we talked about only TCP IP, because they are very heart of this TCP IP protocol. That's why the name is the TCP IP stack or the TCP IP layer concept. The name is also given based on those two mother protocols. But the concept is that whenever you are choosing any protocol, you have to understand what are the overheads that protocol is associating with your data transmission, because that overhead is very important to understand whether that is suitable for your scenario or not. Then only you can choose that protocol for your purpose. That's why we will see some protocols, some types of protocols we will choose for embedded scenario, for some protocols for IoT scenario, and then also case by case also again it is embedded scenario, it is dependent. So that is a very basic brief idea I have given, maybe about what we can expect from a communication framework and how the layers are present and how different protocols are associated with different layers. Again, you can observe just one when I forgot to mention that when we are talking about this IP protocol, we have just talked about how this data is getting segmented and how what are associated fields we are adding with data, that's all. But when we are talking about TCP protocol, there we are talking how this communication is getting actually this is a very basic version of TCP. And there are different things in TCP like congestion control. What will happen? You have some congestion, you are missing your acknowledgement, everything is there. I'm not going into the details, but I'm just giving you the idea that when you are we are talking about protocols mapped to different layers, we are just expecting different things from those protocols. And based on that, we will choose our embedded communication protocols. Now, when we will be starting our embedded communication, that I will start from next day, there we will see that how our there will be two challenges. First one that I have already told you about embedded concept, what we have. Embedded means one small device embedded maybe in a larger device. Okay, that is the basic meaning of embedded. Okay, so when we are talking about embedded, if we just generally think about a CPS framework where embedded system is very prominent, you can see there may be some sensor. That sensor is getting connected to some computing platform, cyber platform. Then cyber platform may be giving some input to some actuation. Then that way maybe there are different types of components. And also when we are going to one level up, multiple cyber physical systems, multiple embedded devices, they are getting connected. And they can carry different types of communications. Maybe voice, maybe data, maybe video signals. There are different types of communication. So there are lots of heterogeneity. So one type of protocol will not suffice. This is one problem, this heterogeneity. And the second problem is, so one problem is heterogeneity. And the second problem is real-time requirement. So first, from next year onward, we will focus on this real-time requirement, how it is affecting the embedded communication, and then we will talk about heterogeneity in different applications, how different protocols are getting used, and what is the purpose of them. That's why if you see the syllabus now, there are so many protocols we have included, like CAN, PIN, CAN, LIN, FlexWave. There are so many types of protocols we have included to understand how the communication will work in different heterogeneous scenarios. Okay. Now this one, maybe those who have done the communication fundamentals or basic courses, they have already seen these two slides. Just for those new students. So you can see when we are talking about embedded system nowadays, embedded system nowadays is not just one computing, one sensor or one actuator. It is like you are having one layer of, one layer of CPS nodes, physical system nodes. They are mainly equipped by embedded systems, smaller embedded parts. These CPS nodes, they are connected to form some CPS units, and those CPS units, huge number of CPS units, maybe LAN of CPS units, they are forming a CPS system. So this is not only when we are talking about, that is the heterogeneity, that is the challenge when we are talking about embedded communication, that we are not talking about just one network, computer to computer communication. We are not talking about just sensor to sensor communication. Here we are talking about communication between sensor, between between computer, between computing scenario, between the actuation framework. Everything, every part should come under this embedded communication network. That's why there are different types of communication protocols and different types of communication needs also. You can see just this example that nowadays these smart cars, maybe this one also you have seen, the smart within a smart car itself, you have so many types of communication protocols. Something for media, something for steering to body parts, something for your driver information control. I mean, in a just within a smart car, there are typical different types of communication requirements. And when this smart car is again going to your IoT framework, then there also these should go for some other types of requirement. Their security will come into picture, and some say other external sensing devices and their communication should come into picture. So that's why lots of heterogeneity is there. That's why the embedded communication are divided into different pillars. Like we will be discussing about vehicular, we will be discussing about smart grid, all these different pillars and their respective embedded requirement and embedded communication requirement. Okay, so this is just an overview of the course, what we are going to discuss about your next few weeks. This I have just talked about my part. Professor Sharkar will be talking about some other dependability, distributed dependability, those parts. Maybe that time he will be introducing his part. Okay, so for first day, I think this is all. From next year onwards, I will start the exact embedded communication discussion. And I'm telling about those students who are not having at all any background of this communication. Maybe few terms, for me it is quite simple. I'm not repeating them, but if you feel any problem, just tell me to stop. I will stop there and I will repeat that term if it is very new to you and if it is not very clear to you. Okay, I will repeat that term, but just maybe you write in the chat or you just unmute yourself and just tell me to repeat that part. Then I will understand that which part is not known to you and which term I should repeat again. Okay. Is there any question? Are you there?
Ma'am, that
Hello, ma'am.
book
Mm.
that you are
Yes, ma'am. Hello.
Yes,
You will
yes,
not
tell
have
me.
it, ma'am.
Yes. Tell me. Can you repeat?
Ma'am, I
Hello?
was saying the book that you were talking about
The
that you
folder is
placed in that
showing empty, ma'am.
communication basic folder. Yeah, we don't find any book in that folder. Can you please
Folder,
check? Have you
the
given that?
communication basic folder, I can see that.
Ma'am, we cannot see it.
Okay, that you cannot see the folder.
Ma'am, we can see the folder, but we can't find the file in that.
Okay. You can see my screen, right?
Yes, ma'am.
It's there. It's shared. Let me check with. Let me check whether I have. Can I check it once? Otherwise, I will try to upload it once again, removing that file. Because this is, I have shared this folder with you. This is inside, so your access should be by default. Can you access through the link I have shared in the chat box?
Yes, ma'am. Link we can access.
No,
We are
ma'am.
able to
The folder is
get
still
syllabus
empty.
and article. Yes,
You
ma'am.
cannot
Folder
access.
is still empty. No, ma'am.
Okay. Wait.
Ma'am, if it's possible that you can upload this in file section of the Microsoft Teams.
Yes, it's possible, but thing is that. But I will be sharing all these documents here, so it's difficult. Can you check with this folder, with this link?
It's still empty.
Still empty. Okay, what I will do. Okay, tell me one thing. This syllabus and all this you can see. Can you see this?
Yes, ma'am. Yes,
That
ma'am.
you can see, right? Okay. Okay. Wait.
This is flagged by the Google team, so you can't share. There is a flag icon right against the public ownership.
Okay. Just okay. Now I move the book to the outside folder that you can access. Can you check it now? What is the flag? What is this flag?
Ma'am,
Flag
Google
for
won't allow
abuse.
the intellectual property shared on its platform.
Don't know why. Okay, I will check it out. Okay, if I can get this is. Don't know why. Okay, I will check if I can get and the PDF of this book. I will share with you. Okay. Any other question? Why it's not coming?
This is
Maybe.
copyrighted stuff.
Yes, I think that's right. But it was openly available. Google. That's why I should.